Rajeshswari Sharma. Is that right?
Yes, sir.
Yeah. Okay. You can start.
Okay, hello, I am Rajeshswari Sharma and I am from Norbadur Bandari Government College, Tadu, is Sikkim. And topic for my presentation is Thomae function. So before moving towards the topic, I just want to do the prerequisites which I needed for this topic. And number one is when we say the function is continuous at A. Let D be a subset of R and the function from D to R is defined and A belongs to D, then function is said to be continuous if for all epsilon greater than 0, there exists delta greater than 0 such that mod fx minus fa is less than epsilon if and only if mod x minus a is less than delta. And second one is density of irrationals, which says that between any two real number, there exists an irrational number. So we are moving forward. What's Thomae function then? Basically, Thomae function is a continuous function which is discontinuous at rationals and continuous at irrationals. It is also known as modified Dirichlet function, and definition is the function from open interval 0, 1 to r given by fx equals to 0 if x is irrational, and image of the function will be 1 by q when x is p by q, that is rational, where p and q are natural number and GCD of p comma q equals to 1. That means p and q are in lowest term. So yeah, today I am discussing about the continuity and discontinuity of this Thomae function. So let us first discuss discontinuity at rational points. So the basic idea, as we all know, that is while doing continuity and discontinuity, we have to estimate mod fx minus fa. Okay, let a be rational, that is a equals to p by q in lowest term, and my claim is the function is not continuous at a, and the proof is by contradiction. So let us first assume that f is continuous at a, and let us choose an epsilon greater than 0 and less than 1 by q. So following the definition of continuity, we know that for epsilon there is delta, such that for all x belongs to open interval a minus delta a plus delta intersection 0, 1, we have mod fx minus fa is less than epsilon. But by density of irrational, we know that in this interval there always exists an irrational number. For this, what we get is fx minus fa equals to fx as it is irrational, x as it is x is irrational, so fx will be 0, and a as it is rational, fa will be 1 by q. So it will give us 1 by q, which will be greater than epsilon, as we have chosen our epsilon to be less than 1 by q. So this will lead to the contradiction. That means what we have assumed is not correct. That is, so what we have assumed is f is continuous at t. If it is not correct, means f is not continuous at t. So we are done with the discontinuity. I think it is clear. Yeah, so discussing about continuity at irrational point. That means now my A is irrational and my FA will be 0. Okay. So any arbitrary R which is irrational, if we take any arbitrary R, then mod FR minus FA will be 0 minus 0. That is of course less than epsilon for every epsilon greater than 0. So we are done with if R is irrational. So what we are going to do is, on what we are looking for is just when R is rational. So let epsilon be greater than 0. Then if we have R equals to P by Q, which is rational, where P and Q are natural number as before and GCD is 1. So it is a rational number between open interval 0, 1. Then the image of this will be 1 by Q by our function definition, which will be greater than epsilon if and only if q is less than 1 by epsilon. So we know that these type of queues exist only there are only finitely many queues. Why? Because if there are infinitely many queues, then since q is a natural number, and if there are infinitely many queues which is less than 1 by epsilon, that will implies that 1 by epsilon will be upper bound of this natural number. But we know that n is not bounded above. So that's why if these will satisfy, only there are finitely many queues. So the idea here is if those rationals whose image is less than epsilon, whose image is 1 by q is less than epsilon, then I don't have to do anything. So I am only looking for the condition where image is greater than epsilon, which is creating problem for my function to be continuous, right? So I will try to control this or avoid this. So let's see how we can control this. For that, let us consider the set of those finitely many queues, which is since they are finitely many, there must be R1, R2, R3 up to Rk, where k run from 1 to n. And since we have to check continuity at irrational points, so A is irrational, A is not equal to any of these Rks. Then mode of A minus Rk will be greater than 0 since they are not equal. And this gives us hint to choose our delta in such a way that we can avoid all these rationals. Like if we can visualize for a second, we can visualize a number line and a point A and all those finitely many. So why I am choosing the minimum is, what if I choose maximum? What will happen? If I choose maximum, then every finitely many will be there in my set. But they are creating problem for me. So to avoid this, we are choosing the delta, or I am choosing the delta, which is minimum of all these rationals. That means I am avoiding or making out from my set. And since they are finitely many, I can do that. So for that, what we get, mode fx minus fa is less than delta. And hence we obtain, for this, what we obtain, mode fx minus fa is less than epsilon. So here, from here, what we have seen is it is continuous at irrational. Okay, I'm moving on. So is the other way true? That means we have seen a function, Thomae function, which is continuous at irrational point and not continuous at rational points. So natural thing what we can ask is the other way around true? That is there any function, or we can create a function which is continuous at rational point and not continuous at irrational point? So yeah, anyone can give a blind guess.
So you can use the reactions also to say whether do you think there is a function which is continuous at rationals and not at irrationals.
People are saying no.
Yeah.
Oh yeah, unfortunately it is not. There does not exist any function which is continuous at rational point and discontinuous at irrational point. And there is also a proof of that. That's all. And the reference I have taken is from basic course in analysis. If anyone have anything to ask.
Anyone have any questions? Okay, so I have some questions. So if you can go to your first slide, yeah, where you were defining the continuity. Yeah, so in this you used something as if and only if, right?
Yeah, sir.
Do you think that is correct?
Yeah, no, sir. One way implies only, no?
Why is this not correct? Can you give an example? Can you think of an example?
No, instead, first, if you can tell which way it's correct.
Okay.
Let's see that which way it's correct. If
fx minus fa is less than epsilon, that implies that mod x minus a is less than delta.
Okay. I think Mugdha has opened her mic. Do you have something to say, Mugdha?
Yes, sir. I was saying that it should be mod of fx minus fa less than epsilon if mod of x minus a is less than delta.
Yes. Can you explain why, Mugdha?
I will have to think a little bit.
Okay. Rajeshwari, did you hear what she said?
Yes, sir.
So can you state the definition correctly now?
Yeah. If function is defined from D to R and A belongs to D, then function is said to be continuous. If for all epsilon greater than 0, there exists delta greater than 0, such that mod fx minus fa is less than epsilon if mod x minus a is less than delta.
Yes.
I also know, sir, what this is typing from.
Okay. Yeah, you were using it correctly, but I think you made a mistake over here.
Yeah.
And think about an example where this would not hold. If and only if you are saying, think of an example that where this if and only if does not hold. Huh?
Okay, sir.
Okay. And then in the next slide, when you were, I think, no, next slide. No, if there are the 1 by q less than epsilon, sorry, q less than 1 by epsilon, you said q has to be finite. This one, yes. If there were infinitely many q's, you said that then natural numbers would be bounded.
Yeah.
Can you think of it a little bit? Yeah.
I'm not able to understand what you are asking.
Okay, can you explain this part again?
Oh, yeah. Okay, first I am, if there is rational number and image will be greater than epsilon, this will only be true if q is less than 1 by epsilon. This is clear.
Yes.
And I am claiming that q are only finitely many. Q are infinitely many. By definition of my function, q is a natural number. So if infinitely many, then the infinitely many natural numbers are less than 1 by epsilon, which implies 1 by epsilon is upper bound of these infinitely many natural numbers. And that will implies n is bounded above by 1 by epsilon.
Will that imply n is bounded above by 1 by epsilon, or a subset, infinite subset of n will be bounded above by 1 by epsilon?
Yeah, infinite subset
Of
natural number
will be bounded, right?
Yeah.
And then you find a contradiction.
Yeah.
Okay. Think about it. Here you have to argue something because you are not getting that n is bounded. You are getting a subset of n which is bounded and which is infinite. Then that will also give you a contradiction, right?
Yes, sir.
Yes. And one more
Infinite subset is equivalent to the set, no, superset. That's why.
But no, there can be infinite set which are bounded, right?
Infinite subset of something, maybe she want to say. So that's something she missed out in explaining.
Yeah. So think about it.
Would you like to rephrase your sentence?
Okay. Think about it. And also one more point. You said R is a rational, which is P by Q. And you said PQ belongs to then n natural numbers, right?
Yes, sir.
Then you are restricting your set of rationals, right? Can every rational be written as P by Q, where P and Q are natural?
No, but here that P and Q are in lowest form. No, that's why I written this.
No, lowest form GCD is one that's okay. but does it have to be like P and Q in natural numbers only?
Oh, sir, my set is from, my function is from 0, 1 to R. No, that's why
Yeah.
only positive numbers are there. So I
Yes.
set of natural number.
Yes. Yes. So because your domain is that, otherwise, if you are saying R is a rational number, then I don't have this, right?
Yeah.
Okay, great. And think about this point. A subtle argument is there. Okay, otherwise it's fine.
Can I make a question?
Yeah, sure.
Yeah, you said you have taken delta is equals to minimum of A minus RK, right?
Yeah.
So for that, we should have finite A minus RKs. Okay. Hello.
Yeah.
So you have proved that there are finitely many Qs. Okay, but how do we know that there are finitely many RK? That means the rational numbers that satisfies.
Yeah. If P by Q is a natural rational number, then I'm looking for the image of that natural number. No? So image is 1 by Q. So finite, if there are only finitely many Qs, from this I can see that only finitely many are creating problem.
No, I'm saying that how do we know that there are finitely many rational numbers such that
Yeah, see, if R is a rational number and image is less than epsilon, then I don't have to do anything, right? So I am just looking for those rational numbers whose image is greater than epsilon. And from this finitely many Qs, what I have gathered is there are finitely many images only which are creating problem. That means what is that? X from the domain, the image of whose are creating problem is finitely many. From that we can say, no.
So you want to say that since there are finitely many images, so therefore there are finitely many pre-images, right?
Yeah.
But I'm questioning that how there are finitely many pre-images. Means how can you say that there are no infinitely many rational numbers whose images are finite?
Yeah, you have a good question, but I think I have to think about a little bit.
Yeah, okay. I have some reason, but I don't know it is correct or not. If P by Q is belongs to 0 to 1, then P is less than Q, right? So this says that there are finitely many rational number whose images are finite.
Yeah,
I think
a nice observation. P is less than Q, no, so yeah, they are finite.
okay, thank you.
All right.
Any other questions or remarks? Okay, then let's all thank Rajeshwari for her presentation, and we hope that you will think about the things that were missing, and also about the proof that you asked in the end, that why there can't be any function, right? Which is
Yeah,
continuous on rational and discontinuous on irrationals, right?
of course, sir. Thank you so much.
Okay, good. Thank you, Rajeshwari.